characteristics of the octal number system are as follows. So uses 8 digits 0, 1, 2, 3, 4, 5, 6, 7, and also called as base 8 number system. And each position in an octal number represents a 0 power of the base 8, example 80. And last position in an octal number represents a x power of the base 8, example 8x, where x represents the last position, -1. Okay, so example, if we have the octal number 125708, and what's the decimal equivalent of it? So what we can do is just 1 times 0, 1, 2, 3, 4. So 8 raised to 4 plus 2, 8 times 8 raised to 3 plus 5 times 8 raised to 10, 2 plus 7 times 8 raised to 1 plus 0 times 8 raised to 0. So since decimal number is base of 10, so we will that's sub 10. Okay, that's the correct kanina. Okay, so if we kung ni-multiply and add natin to lahat-lahat, it's equivalent to 5,496 sub 10 for decimal number. Okay. So note that 12570 sub 8 is normally written as 12,570. Okay. So let's do the hexadecimal number system. So hexadecimal number system has 16 symbols. So lahat naman to nasa 16. And 0 to 9 and A to F, where A is equivalent to 10 and B is equivalent to 11 and on till F. The hexadecimal number system is also a positional value system where each digit has its value expressed in its power of 16 as shown here. So 16 raised to 5, 16 raised to 4, 16 raised to 3, 16 raised to 2, 16 raised to 1, and 16 raised to 0. So the characteristics of the hexadecimal number systems are as follows. So uses 10 digits and 6 letters, 0, 1, 2, 3, 4, 5, 6, 7, 8 to 9, then A, B, C, D, E, F. Okay, so letters represents numbers starting from 10. So A starts to 10, B 11, C 12, D 13, E 14, F is 15. It's also called as base 16 number system. So each position in a hexadecimal number represents a 0 power of the base 16. And example 160. So the last position in an hexadecimal number represents a x power of the base 16. And example 16x, where x represents the last position 1. Okay, so decimal equivalent of any hexadecimal number is sum of the product of each digit with its positional value. So for example, 27FB and F, what's the equivalent? F is 15 and B is equivalent to 11. So 2 times 16 raised to 3. So sabihin natin itong 0, 1, 2, 3. So 2 times 16 raised to 3 plus 7 times 16 raised to 2, and this is equivalent to 15 times 16 raised to 1 and 10 times 16 raised to 0. So okay, so the answer is 10,234 sub 10 because decimal number is a base 10. Okay. So example, hexadecimal number 19FDE16. Yan. So gawin din natin siyang decimal. Okay, so decimal. Okay? So 19, 1 times 16 raised to 4 plus 9 times 16 raised to 3 plus F times 16. Raised to 2, D times 16 raised to 1 plus E times 16 raised to 0. Then the binary is 10. Okay. By binary, the sub 10. Okay. The base is 10. Then, yung F natin, ginawa natin 15. Then yung D, it's equivalent to 13. And E is equivalent to 14. then the answer is 106,462 base 10. Okay, sub 10. So what's the number system relationships? So the following table depicts the relationship between the decimal, binary, octal, and hexadecimal number system. So in hexadecimal, it's equivalent to 1, 2, okay, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Tapos A to F. Okay? Okay, by the way, may mga nadaanan na tayong mga clue. So, this another clue, it's letter O. So, yung sa decimal, so as you can see, it's always base 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And ito naman, equivalent niya, ang A is 10, B 11, C 12, D 13, E 14, and F 15. Okay, how about the octal? 0, 1, 2, 3, 4, 5, 6, 7. And yung ika-8, since it's octal, start na tayo sa 10. Okay? After ng 10, and yung suppose, di ba 0 to 7 lang naman is yung octal. So, after that, it's 10, 11, 12, 13, 14, 15, 16, and 17. Okay? So, binary. So, 0, 0, 0, 0. Tapos, dito, start na yung 1. Tapos, yung 2, dito na nag-start yung binary natin. Then, yung 3. Okay, yung 3, because it's 2 plus 1, yan. 3 na yan. Ito, 4. Dito na yung 4. 0, 1, 0, 0. Then, 5, 0, 1, 0, 1. Then 6, 0, 1, 1, 0, and 7, 0, 1, 1, 1, and 8, it's 1,000, 9, 1, 0, 0, 1, dito, okay, balikan natin. Then, balik naman dito sa 10, 1, 0, 1, 0, then 1, 0, 11, ito, 1, 1, 0, 0, then 13, 1, 0, 1, 0, 1, and 14, 1, 1, 1, 0, and 15, it's 1, 1, 1, 1. So, there are many methods or techniques which can be used to convert numbers from one base to another. In this chapter, we will demonstrate the following. So, decimal to other base system, and other base system to decimal, then other base system to non-decimal, shortcut method binary to octal, shortcut method to octal to binary, a shortcut method, a hexadecimal to binary. Okay, so tignan natin, isa-isahin natin. For the decimal to other base system, step 1, you should divide the decimal number to be converted by the value of the new base. And step 2, get the remainder from step 1 as the rightmost digit, least significant digit of the base number. And step 3, you should divide the quotient of the previous divide by the new base. And step 4, record the remainder from step 3 as the next digit to the left of the base number, of the new base number. And repeat the steps 3 and 4, getting remainder from right to left until the quotient becomes 0 in step 3. So the last remainder that's obtained will be the most significant digit MSD of the new base number. So the decimal number, for example, 29 base in base 10. So step 1, no? 29 over 2, so this is the operation, and the result is 14 and the remainder is 1. Okay? So step 2, 14 na tayo, divided by 2, then it becomes 7, then this is 0. 0, because it's 0. 7 over 2. It's 3. Okay, 3. Then this remainder niya is 1. Okay, so 3 over 2, it's 1. And meron siyang remainder na 1. And 1 over 2 is 0. And merong remainder na 1. Okay, so as mentioned in step 2 and 4, the remainders have to be arranged in the reverse order. Reverse, so pabaliktad. So that the first remainder becomes the least significant and the last remainder becomes the most significant digit. So yung most significant digit is yung parang most left and the least significant digit is nasa most right. Okay, so magiging yung binary number natin, yung 29 base 10 natin, become 11101 2. Okay? So 2. Click na natin 11101. Yan. So, yan po ang nangyari kung bakit nagkaroon tayo. Ganyan po yung binary natin. Hopefully naintindihan niyo. Okay, so other base system to decimal system. It's step 1, determine the column positional value of each digit. This depends on the position of the digit and the base of the number system. Step 2, multiply the obtained column values in step 1 by the digits in the corresponding volumes. And step 3, sum the products calculated in step 2. The total is equivalent value in decimal. So, the example is in here. Ito yung binary system natin, di ba? 11101 base 2. So, actually, kanina nagawa na natin to. So, inulit ko lang just a review. Then, other base 2, non-decimal na system. So, step 1, you should convert the original number to a decimal number base 10 and convert the decimal number so obtain to the new base number. So, octal number 25, octal number 25. So, calculating binary equivalent. Okay, so, katulad pa rin to ng kaninang pinakita ko. So, this is just a review. Okay, we have another clue is letter R. How to convert the decimal to binary. This is another example. 21 over 2, 10, then may remainder na 1. Right? So, 10 divided by 2, 5, wala siyang remainder, so it's 0. So, 5, remainder of 2, so it's 2, remainder divided by 2, so answer is 2, and may remainder siyang 1, and 2, remainder of, 2 over 2 is equivalent to 1, and there's no remainder, and 1 over 2 is, the result is 0, then the remainder is 1. So, ang gagawin natin, babalik na natin. So, 10101. So, yun po yung sabi niya. Ano bang nyo kakalimutan na? It's pag binary 2, pag decimal number 10, pag octal number 8, pagka... Okay. So, nakita ninyo, the octal number is 25, so 8. Then, yung decimal number 21, so base 10, and ito yung binary. Right, so ito yung mga shortcut method ng binary to octal para mas makita natin. So, divide the binary digits into groups of 3 starting from the right. Convert each group of 3 binary digit to one octal digit. So, okay. So, example, the binary system is 101012. So, paano natin kung gagawin to octal number? Okay, so 101012, ang gagawin natin dyan, 10101. Okay, so